Okay, today our topic is to learn about solving modulus equations. We are going to learn solving modulus equations. Solving modulus equations. We'll get a very basic modulus equation. Let's try to solve this equation. We'll get modulus of x plus 2 is equals to 4. There are two approaches where we use to do this question. Is the first approach is a graphical approach, and the second approach is the numerical approach. From the graphical approach, we can go to an answer up to a certain approximated answer. From the numerical approach only, we can go ahead with the correct answer for this solution. Right. Let's see how to do this kind of a question. Right. Initially, come up with a graphical approach. We will draw the left hand side equation, that is y equals to modulus of x plus 2 graph. If you draw modulus of x plus 2 graph, it's just like this. It's traveling through 2 and up to minus 2, and it will reflect like this. This is the equation of y equals to modulus of x plus 2 graph. Right. Then I will use a different color for that. I will draw y equals to 4 graph. It's a horizontal line which travels through 4. This is y equals to 4 graph. Right. Then the intersections of these two. You can see there are two intersections, or you can obtain. If you draw this graph, what you call perfectly, without having any what you call transformations exactly, you can get the solutions. First solution and the second solution. Right. Now, the problem what we come across the graphical representation is to get it to draw it, you have to draw it perfectly to draw it. Like without getting this kind of hesitation, let's see how to use this numerical approach to get this solution. Right. And now I'm going to teach you how to use a numerical approach to get this answer. Yeah, okay, let's go ahead with this. Right. Then we need to solve modulus of x plus 2 is equals to 4. Right. To solve this modulus equation, we use the definition. We use the definition of modulus functions. Instead of so what is the definition? If I review the modulus of modulus function, it's this. So you can write the same function instead of the modulus. Under which condition? If the fx is greater than or equals to 0. Under that condition, you can write the same thing for the modulus. If you put a minus in front of, and you can write the function inside the modulus for the cases of fx is less than 0. We use this definition to answer this question. Right. So instead of this modulus of x plus 2, I can write same x plus 2 under which condition? X plus 2 is greater than or equals to 0. That means this is valid for the range where x is greater than minus 2 only. Right. Now let's try to get this answer for this question. Then you can say x is equals to 4 minus 2. That is x equals to 2. Now check whether this answer is within this range. X is greater than minus 2 means which range? So you can say that minus 2 onwards. Now you can see 2 is a point somewhere over here which is within the range. Therefore, this answer is a valid solution. That means you can say, yes, this answer is 2. Right? That is the approach you can get it now. The second fact of it today. The second fact of it is, instead of this modulus of x plus 2, I can write with a minus in front of it. Under which condition? If this x plus 2 is less than 0. Right? Then we'll try to simplify. That means where x is less than minus 2. See, it's obviously the opposite region than from here, minus 2. It's equal is not there, therefore I just write the dot, what do you call this, circle over here, not a colored circle. Then minus x minus 2 equals to 4, minus x equals to 6, x equals to minus 6. So obviously you know that minus 6 is somewhere over here. This answer also another valid solution. So this answer is minus 6. Therefore you can write the answers. Answers would be x equals to 2 and x equals to 6. Those are the solutions for this modulus equation. That is the way of understanding the solutions for this question, right? That's a way of it.
The minus 6.
It's my, yeah, minus 6 because, sorry, yes, sorry. Thank you. It comes with minus 6, right? Okay, that's a way of getting the answer for this question. Now let's come up to the another example. Okay, we will go ahead with this, come up with this. Then we need to solve modulus of 2x plus 1 is equals to x plus 3. Right, x plus 3. Right. Now let's go ahead with this question today. Initially, we need to draw. We'll go ahead with the graphical solution because graphical solution gives you some kind of idea about this graph. That is why we go ahead with these graphical solutions today. 2x plus 1, the modulus. So it's traveling through 1. And over here, it's traveling through 1 over 2, minus 1 over 2. If you draw the modulus graph, it's a shape like this. It's a shape like this one. Then this is the first part of the equation, y equals to modulus of 2x plus 1. Right? Then the other one is x plus 3. Right? I'll use a different color for that. If it is traveling through 3 and it's traveling through minus 3, it's a straight line, just traveling through these points. My drawing is not that good. So we'll get this point as 3. 3, right, okay. Then for this case, but then definitely we know that there is a 1 intersection over here. Similar to B, this one also having some kind of an intersection over here. These are the practical problems where we come across, right? Sometimes like we cannot see whether these intersections are existing or not. Yeah, visibly seems to be they are intersecting. Yeah, they are intersecting. But this kind of situations are there sometimes from the graphical approach. We cannot 100% say it in an accurate form, whether this is correct or wrong, whether this happens or not. But in this numerical analysis, we don't have that kind of a problem. Let's go ahead with this. We need to solve this one. 2x plus 1, the modulus is equals to x plus 3. We'll go at the first definition. That is 2x plus 1 is equals to x plus 3. Instead of this modulus, I can write 2x plus 1 over here. Under which condition? 2x plus 1 is greater than or equals to 0. That is 2x is greater than or equals to minus 1. X is greater than or equals to minus 1 over 2. That means from minus 1 over 2 onwards, including minus 1 over 2. Let's solve this. Then you can say 2x minus x equals to 3 minus 1. X is equals to 3 minus 1 is 2. Right. That means 2 is a value somewhere over here, so it is correct. Okay. This answer x is. Right, we'll go ahead because still we don't have evidence to say whether like this is the point. Maybe I think there is a point, but we'll go ahead with the other one as well. Instead of this modulus, you can put a minus in front of it, and you can do this x plus 3 under which condition 2x plus 1 is less than 0, not equal. So minus 2x minus 1 equals to x plus 3. Brought all the terms to one side. Minus 2x equals to minus 1 minus 3. It's minus x equals to minus 4. Have I done something correct? No, it's plus 3x. 3x equals to minus 4. Therefore, x equals to minus 4 over 3. Then I think this is condition x is less than minus 1 over 2. Minus 1 over 2, including this minus 4 over 3 somewhere here. So this answer is also correct with it. Now you can see, so this is the fact. It's minus 4 over 3. And definitely there's an intersection. That is the answer for x equals to 2. So you can write the answers would be x equals to 2 and x equals to minus 4 over 3. These are the solutions for this modulus equation. Hopefully that is fine with you. Right, let's go ahead with another example. Let's see, we need to solve modulus of 2x plus 1 is equals to 3x minus 2. Right. We'll go ahead with this today. Graphically, if you draw this, you can see it traveling through 1, and over here it's -1/2. So the graph goes like this way around. Right. Now make +2, other than that. Comes with this, then the second one. This is the y equals to modulus of 2x plus 1. Right. Then I'm going to draw, 3x plus 2. It's traveling through 3, and the intersection comes at 2/3. It's a point somewhere over here, -2/3. So it's a graph like this. Right. Seems to be having a more gradient than this. Still, we don't know whether like seems to be whether there's a intersection over here, but this intersection is for sure. But still, we have a doubt that whether there's an intersection over here. To find it, we can use this numerical approach for this. So you can simply write, we need to solve 2x plus 1, the modulus is equals to 3x plus 2. So instead of this, you can write 2x plus 1 equals to 3x plus 2, under which condition 2x plus 1 is greater than or equals to 0. That is, x is greater than or equals to -1/2. I'm not spending much of time on that because that is the same thing what we did in the previous question, including -1/2 upwards figures. So you can say 3x minus 2x is equals to 1 minus 2. So it's turned up to x is equals to -1. Yes. X equals to -1. You can see the 0 is here, -1 is a value somewhere over here. Therefore, we cannot expect this solution. We cannot expect this solution, right? Okay, so that is not, this is not a reasonable solution, seems to be. Okay. Then you can put a minus in front of it and you can write it. 2x plus 1 equals to 3x plus 2. That is -2x minus 1 equals to 3x plus 2. 3x minus plus 2x is equals to -1 minus 2. It's 5x equals to -3. Therefore, x equals to -3/5. So that is a solution over here today. -3/5. So in this case, this opposite range, 2x is less, 2x plus 1 is less than 0. That is, x is less than -1/2. -3/5 is somewhere over here. So it's fine. Yeah. So this answer is x is 3. So with this, you can say the answers for this question would be, what is it? X equals to -3/5. So there is no intersection over here. So if you refer with that, you don't see any kind of intersection over here. It seems to be from, if you draw it perfectly even, you will understand that the graphs are going like this. So there is no chance of forming a intersection over here if you draw it perfectly. That's how it comes with it. Yeah, let's go to the another question and try to verify this theories with it. Let's see, we need to solve. This is little bit important question. Modulus of x squared plus x minus 6 is equals to, we will get equals to 4. Right. Initially, we need to draw y equals to modulus graph. The modulus graph over here is, it's -3 and 2. So if you draw the modulus graph, this goes to this side. You already learned how to draw this. Then you can draw a graph like this, where this point is 6. If the topic is somewhere over here, and this is the y equals to modulus of x squared plus x minus 6. Then y equals to 4. I will use a different color for that. This is y equals to 4. Right. Then how many solutions we can expect? We can expect 4 solutions. Yes. From numerical approach for this kind of a graph, the drawing is kind of hard. That is why it supports us with the numerical solutions. Right? We'll go ahead with this. When you're drawing these numerical solutions, it's kind of important because we have to follow up certain inequalities with this. Modulus equals to 4. Initially, instead of this modulus graph, you can say x squared plus x minus 6. You can write instead of modulus, you can write the same thing equals to 4. That means x squared plus x minus 6 minus 4 equals to 0. That is x squared plus x minus 10 equals to 0. So if you solve this quadratic equation, you will receive the answers 1, 1 and minus 10. So you get the answers, these answers. But the first answer is x equals to minus 1 plus root 41 divided by 2, approximately 2.7. 2.7. Other answer is x equals to minus 1 minus root 41 divided by 2. That is approximately minus 3.7. Now we need to see whether these solutions are valid or whether part of a solutions are valid or whether both solutions are not valid. So let's see. To form this, instead of this modulus, you can write this one under which condition? If this x squared plus x minus 6 is greater than or equals to 0 only. If you solve this quadratic equation, it's traveling through minus 3 and 2. Now you can see this graph. We know how to solve this kind of a quadratic inequality, This region over here I am referring to this area. This is positive. This area is below the x-axis, it's negative. And again after 2, it's positive. With this you can write, this is the required area. Sorry, greater region is this region. This is the reference region where we need to see. Right? Okay. With that you can write this way. The referred region is this bit, this region and this region. Now check whether these solutions are into this one, 2.7. It's here. Therefore, this answer is correct. Minus 3.7. It's here. That one also, this answer also correct. Therefore, both solutions are accepted. Okay. Then let's go to the next part of it today. Instead of this modulus over here, you can write with minus in front. Plus x minus 6 is equals to 4. So you can say minus x squared minus 6 plus 6 minus 4 equals to 0. Minus x squared minus x plus 2 is equals to 0. With that, you can obtain the solutions for this. Minus 1, and 2. You get one solution is x equals to 1. Other solution is x equals to minus 2. Now we have to see whether these solutions are accepted. That means this is correct. You can put a minus in front of it under which condition? X squared plus x minus 6 is less than 0. Then obviously we know that is the opposite region of this. This is a greater region is this means opposite region is from here to here. So no need of working out again and again, and you can see this answer over here and here. Right. Minus 2, it's somewhere here. So this is fine. 1, it's somewhere over here, and that one also fine. With that, you can say all 4 answers are correct. So if you just go to the graph and let's try to figure out these figures. Minus 2 is somewhere here. This is the minus 2 figure. 1 is somewhere over here, right? The next one is this one, 2.7. That answer is here. That is minus 1 plus root 41 divided by 2. It's here. Over here only you can see minus 1 minus root 41 divided by 2. This is 41 today. 41. Yeah, like that you can get this answer for this kind of a question. Let's go ahead with this. Right. Let's go to another example and try to figure out this. Let's see, we need to solve this quadratic inequality to get x squared plus 2x minus 8 is equals to, initially I tried out with the easier ones, right? Then equals to, we will get it's called we'll put it as plus 9. Right. Let's try to draw this graph with it. So if you sketch this graph, you can see it traveling through -4 and +2. So it's a graph like this. It's -8, sorry, +8 actually. Then if you draw +9 for there, you can see it's a graph like this way around. Y equals to 9. It is y equals to modulus of x squared plus 2x minus 8. Then what you can get here, then you can write this is x squared plus 2x minus 8 modulus equals to 9. This is the equation we need to solve. Right. We'll go ahead with this. Initially, you can write the same thing instead of this modulus under which condition x squared plus 2x minus 8 is greater than or equals to 0. That means x squared plus 2x minus 17 is equals to 0. Okay, but right, then you can say x, we can get the solutions for x would be, we'll see with that, 3, it's 1, 2, and minus 17. One answer is -1 plus 3 root 2. -1 plus 3 root 2, it's approximately 3.24. You just get this answer, it's kind of easier for you to understand it. The next value is -1 minus 3 root 2. That is approximately -5.24. Then let's work out with this today. If you solve this quadratic inequality, initially we can equate it and get it. That is -4 to 2. It's easily, this is the same thing you can draw here. Now you can see from this case, this part of the graph is positive because it's above x-axis. This part is, sorry, it's not, it's negative. This part of the graph is negative. Again, this part of the graph is positive. They are referring to the positive graph. And over here to here. That means this is the reference range, right? Then it's here. This is the range we are referring to. This is the range we are referring to. Positive range. Then we can see 3.24. 3.24 is here. It's good, right? -5.24, it's here. That's one also fine. So these two values are falling into that range, right? Okay. Then the next part of it with it, right? So you can say, then instead of this modulus, you can put a minus in front of it and write it. 2x minus 8 equals to 9. With this, you can say minus x squared minus 2x plus 8 minus 9 equals to 0. Minus x squared minus 2x minus 1 equals to 0. That means, but obviously, the range comes to this one, x squared plus 2x minus 8 is less than 0. So nothing to panic with this. It's a exactly direct opposite direction of opposite inequality region of the previous part. So you can mark it, right? Okay. Then from here, you can get the answers for x with it. Let's see what are the answers what you obtain for x. It's -1, -2, and -1. Obviously, it's turned up to -1. It's only one solution where it falls into -1 here. So this answer also fine. Now you can see that is why you can see here is only 3 intersections. Here one intersection, here one intersection, and here there is another intersection. So with that you can write the solutions as x equals to -1, x equals to -1 plus 3 root 2. Other one is x equals to -1 minus 3 root 2. Those are the solutions for this quadratic inequality. Right? That is how it comes with it. Right. Then that is how we need to do this kind of a question. Right. Okay. Let's go to another question and let's try to make sure with this with another example. Right. We'll come up with this. We'll get. I'll get the same inequality -8 modulus is equals to x plus x minus 2. Right. Initially, if you draw this graph with it, so you can say it intersect at -4 and +2. It goes like this and it traveling through 8 and it's -2 means you can see it's traveling through 2, -2, and so when you're drawing here, put there the next graph of it. That is a point we come across. I will just draw with the different color. Now it traveling through these points, put there. But I don't know after this point whether there is an intersection over here with here, but pretty sure I have this intersection. And this is kind of a contradictory point. So that is the points where we cannot understand whether these ones are intersecting further or how many solutions are existing, how many intersections you can expect. That is those are the disadvantages of drawing this graphical approach. But we'll go ahead with the numerical approach to make sure answer these questions today. Plus 2x minus 8 modulus is equals to x minus 2, right? Okay, then you can say this is x squared plus 2x minus 8. You can write it instead of that x minus 2. So because I was explaining the previous inequality, the same inequality I just referred with. Therefore, for the first part is inequality is this bit, -4 to 2. So I'm using the same conditions over here. -4, including -4 and to 2, including 2. So this is the region. Now I'm going to do not going to do this inequality again because we already done this in the previous example, but in exam you have to do it. So it's x squared plus x minus 6 equals to 0. From here you get the answer x equals to -3 and x equals to 2. X equals to 2, yeah. Then put a -3 is a value over here, so it's not in the range. 2 is a value over here, yeah, it's correct. This 2 is a one solution. Put there. Okay. Then let's go to the another solution over here. So you can say x squared plus 2x minus 8 with a minus, you can write it x equals to -2 under which condition? The opposite region for this 2. So it's here to here. It's the region we are referring to. Right. Then if you solve this inequality, minus x squared minus 2x plus 8 minus x plus 2 is equals to 0. Then you can say this is minus x squared minus 3x plus 10 is equals to 0. Let's get these answers. If you just get these answers, -1, -3, and 10. Then the solutions are x equals to 2. The other one is -5. Here the 2 is not included, and here's -4 also not included. -4 also not included over here, -5. So this is not a solution for the 2. It's here, but it's not included here. So this one also not gain an answer. So we can see only one answer is there, that is x equals to 2. So this is the advantage of learning this numerical method, because from the graphical method, this point we are a little bit of contradicted whether this is happening or not. So we can answer those questions easily from the method where we use with the numerical approach for this. So therefore, remember that always going with numerical approach is required. By the graphical approach can you can obtain up to certain extent the solution. Therefore, draw the graph and get the rough idea. Then after that, go ahead with the numerical approach and obtain the final answer for this. That is the way of doing this kind of a question.